Hello, this is Mr. Stansbury. I'm going to take you through some of the problems from the 15C assignment. Okay, first one we're going to take a look at here is number 1. Suppose x is normally distributed with a mean of 20, standard deviation of 3. Illustrate with a sketch and find k such that our probability of x is less than or equal to k is 0.3. So to illustrate that with our sketch here, we're going to draw ourselves a little normal distribution, right? And then what we've got here is here's our mean, okay? And then what we want is we want the lower 30%. So what we can do here is say all this shaded area in here, that this here is 0.3. That's the lower 30% of the data, okay? And we know that our standard deviation here is, our mean is 20. We don't know what this line is right here. That's what we're trying to figure out. Below what value is 30% of the data going to be, okay? So in order to do that, what we want to do is we want to go into second variables, which is our distribution. Instead of using the normal CDF, we're going to actually use the inverse normal. Okay, so whenever they give you a percent and you want to find the value, we're always going to use the inverse normal, because normally we have the value and they're having us calculate the percent. So now it's doing the opposite of that. So that's the inverse of the normal curve. Okay, so we do inverse normal. The area that we're looking for is the bottom 30%. So we put 0.3. The area is always going to be a percentage as a decimal. Standard deviation in this case here is, let's see, the mean, is 20. And then our standard deviation is 3. Okay, now if yours happens to have this, we're going to want the left tail because we want the leftmost. Some of yours don't have that, and it's okay if you don't, because what it will do is it will automatically default to always be the left side. Okay, so it's most like the older calculators in 83s, TI-83s, and so always start from the left and move over. Okay, so that's what we want anyway. So we will have to go down here to paste, push enter, and then enter again, and that gives us that this value right here is going to be about 18.4. Okay, that's what we're looking for. Okay, for E, probability of x is less than k is 0.62. So again, if we're going to draw ourselves our little normal curve here, here is 20, and we want to know from the beginning, because it's less than k, the top 62%. So what we want to do here, we're going to look for this value right here. And over here in this graph here, this is going to be 62% of the data. So it should be something a little bit bigger than 20, right? Okay, so it's going to be all this stuff in here. Okay, so we're going to do the same thing with our inverse normal. So let's do second variables, which is distribution. Go down to the inverse normal because they're giving us the percent. The area now that we want is 0.62. And our mean here is still 20, and our standard deviation is still 3. We still want the leftmost. And even if we do want the rightmost on this video here, I'm going to probably always show you the left, because not all calculators have this on here. So I might show you a little bit of both. But anyway, paste. And that gives us that this value right here is going to be about 20.9, about. Okay, let's see, next one we're going to take a look at is number 3. Suppose x is normally distributed with a mean of 30, standard deviation of 5, and the probability that x is less than or equal to a is 0.57, or 57%. Using a diagram, determine whether a is greater or less than 30. So let's draw ourselves a little normal curve right here. Our mean is 30, and we want to know what goes up to 57%. So that's going to be a little bit more, because 50% is going to go up to 30, right? So this here, this is all going to be our 0.57. So using a diagram, determine whether a is greater than less than 30. It is definitely going to be greater than 30, because it's more than 50%. Okay, and then use technology to find what A is. So that's where we use our graphing calculator for. Let's see. Well, we're just going to have to move it because we've got all sorts of different data here. Okay. So we're going to do second variables, which is our distribution. They gave us the percent, so it's inverse normal. The percent that we're looking for is 0.57. So 0.57, 57, top 57%. Mean is 30. Standard deviation is 5. And it's got the left, and that's good because we want to find the leftmost, and push paste and enter. And we get 30.88. So we're going to call this number here 30.9 about. Okay. Okay. So 57% of the data is less than or equal to about 30.9. Okay. Okay, taking a look at the next one here. Number 7, the lengths of a fish species are normally distributed with a mean of 35, standard deviation of 8. Fisheries Department has decided that the smallest 10% of the fish are not to be harvested. What is the size of the smallest fish that can be harvested? So, again, if we draw ourselves a little picture here, here's our mean, which is 35. And they want to know what the smallest 10% is. So it's this right here. That's 0.1. Okay, right? 10% as a decimal is 0.1. Okay. So what we want to do here, second variables, go to inverse normal because they gave us the percent. Area is 0.1 as a decimal. Mean is 35. And our standard deviation is 8. We want to do the left. And again, some of yours will not even give you the option. It will automatically default to give you the leftmost. And that value right here is going to be 24.7 about. About 24.7 centimeters. So any fish that's 24.7 centimeters or less needs to be not harvested. Okay? Okay. Last one to take a look at here. Number 10, the volumes of cool drink in bottles filled by a machine are normally distributed with a mean of 503 milliliters, standard deviation of 0.5 milliliters. 1% of the bottles are rejected because they are underfilled, and 2% are rejected because they are overfilled. They are otherwise kept for sale. Find correct to 1 decimal place the range of volumes in the bottles that are kept. Okay, so again, I think it's handy to draw a picture on this here so we can see what's going on. Here's our mean of 503. Okay, and what we're trying to find is 1% of the bottles are rejected because they are underfilled. So we want to find this amount here. This is 1%, that's 0.01. And then we also want to find this value here, which is 0.02, the top 0.2%. Okay, so we want to find these two values. Now, to find this one here, pretty straightforward. Okay, just like what we've been doing before. So we're going to do second variables, inverse normal. The area here is 0.01 because it's 1%. The mean 503. Standard deviation is 0.5. Okay, and then it's going to automatically go to the left, and that's good. That's what we want. Okay, and we push enter, and this low number here is going to be 501.8. Okay, so that's our low number, 501.8 milliliters. 2, and now we got to find out what this milliliter number here is. Okay, so now there's a couple ways to do this. What we're looking for is we want to actually, like when we do our inverse normal and we do our left, remember how we always have this like left piece over here? What we want to do is we actually want to find like the top 2% are overfilled. So what we want to find is how much it is from all the percent from here up to here. So really that's going to be 100, or how about this? 1 minus 0.02, which gives us 0.98. We want to know what the top, we want to go up to 98%, because we know the top, that 99 and 100% there, that is too much. That's overfilled. So we want to find 0.98. Okay. So we're going to do second variables, inverse normal, and we want to know what the 98th percentile basically is, because again, anything over that is going to be too full. So 0.98, and then our mean and standard deviation are still the same. We're going to leave it at left, push paste, and we get 504.0. Okay, so that top value there is 504.0 milliliters. Okay, and that's our range. Now, for those that want to, you can actually go through and actually find the top 2%, I believe. Honestly, I haven't tried this before, but as I am understanding this calculator, I'm pretty sure this is what it means. So if we want to find the top 2%, we should be able to leave the 0.02 in there, and then go down. And now the tail, we want the rightmost tail. So this is going to, as I understand it, that means it's going to find it from the right. So if we do that and we push paste, we should get the exact same number. And look, there it is, 504.0. Okay? Okay, that's all we have for the 15C assignment. If you have any further questions, please feel free to ask. Thanks.